So we've been looking at trigonometry problems where we've been given these side lengths and these angles and we're trying to find the unknown, but there's been no context or meaning to them. So that's where trigonometry application comes in, where we're given a scenario and we're asked to find something with a context. We still follow the exact same process. I've still got my steps here, except in some cases you will be asked to draw a diagram and then identify that triangle within the diagram, which enables you to use trigonometry to solve the question. So, in this problem, we have a little ant. I'm a terrible drawer. And this ant has seen a big plane, obviously not to scale, directly above it. And this plane has taken off directly 125 kilometers from that ant. And we're also told that that plane climbed at an angle 15 degrees to reach where it is now. And what we want to find is how high that plane is, which would be where I've labelled H. So we've got our right angled triangle. Now we need to label each of the sides and determine which ratio to use. Opposite my right angle is my hypotenuse. Opposite my reference angle is my opposite, and then the other angle is the adjacent. Okay, so I can get rid of that hypotenuse because I want to find this H value here, and I've got my A. So I'm going to have a look up here at the different ratios and eliminate those ratios with the hypotenuse needed. So I'm going to be working with tan. So over here, I'm going to write out my formula, tan of theta equals the opposite divided by the adjacent. And next I'm going to substitute those values that I know into the formula. So I've got tan, my angle is 15, equals my opposite value, which is the height we're trying to find, divided by the adjacent. Now, if you have your summary notes in front of me from the last video, you'll be able to identify that this is a type 1 question, where our unknown value is the numerator of our fraction. And that means I'm going to take this bottom value and multiply it by both sides. And so my next line is going to look something like this. 125 tan of 15 is equal to our H value. And then what happens is this goes in my calculator, and remember that there's a multiplication in between there. So I'm going to enter 125 multiplied by that tan of 15 degrees. And I'm left with 33, and I'm rounding to 2 decimal places, 0.49 kilometers is equal to H. So we can make a conclusion that the plane is 33.49 kilometers above the ant. So there's a question that has a little bit more context or meaning to it than one of those questions that we looked at last video. Let's have a look at this question. Same process, we need to draw the diagram first. So we've got a staircase that has risen 30 centimetres for every 50 centimetres. Oh, that wasn't very straight. Oh, goodness. That's better. 50 centimetres it goes across. Find the angle to the nearest degree at which the staircase rises. So I'm just going to join these 2 points together, and we can see that this is our right angle. The angle that the staircase rises. Okay, so that's going to be this angle here. Let's label our side lengths. Hypotenuse, reference angles here, opposite, adjacent. So we can get rid of those those ratios again that have hypotenuse in them. Again, we're going to be working with tan. So tan of theta equals opposite over adjacent. Substituting what we know, which in this case we're going to be finding that angle. So we've got our opposite is 30 over 50. And then remember, this is a type 3 question, so we're going to take the inverse of tan. So we're going to be left with theta equals the inverse of tan 30 over 50. And if you're using the green calculator, you're going to press the second command, and then tan, and then enter that 30 over 50. And we want the nearest degree. So on my calculator, I've got 30.9637. So to the nearest degree, that's going to be 31 degrees that the staircase rises at 31 degrees. Okay, so now I think this should be enough preparation for you to go and tackle some application problems for yourself.